This is Chapter 5.2, Exponential Functions and Graphs Notes, Part 4. If you're not watching this through Edpuzzle, you're not getting credit for it. Don't watch it through YouTube. Last portion of Euler's number, we're going to look at transformations of the graph e to the x. So again, same thing as what we did in video 2. Your base graph that you're getting at is e to the x. That's our base graph for all of these. We're starting with y equals e to the x, and then we're going to transform them. This specific one has 3 different transformations. I wanted to remind you of vertical and horizontal stretches and shrinks. So remember, if it's in front, like this, it's a change in y, so that means it's a vertical stretch or shrink. Remember that if the number is bigger than 1, that means it's a stretch. If the number is in between 0 and 1, that means it's a shrink. Remember that the negative does something different than the 3. So those are 2 separate transformations. The negative here means it's a reflection. Since it's right next to the x's are changing, so it's a reflection over the y-axis. And then the 3. The 3 is right next to the x, so that means it's a horizontal stretch or shrink. Remember that these are the ones we have to be very careful of. Horizontals are change in x's, so they're opposite. So if the number, we have to flip it, right? So you have to flip the number. So in our case, our number is 1/3. If the flipped number is bigger than 1, that means that it's a stretch. If the flip number is in between 0 and 1, that means it's a shrink. So multiplying our x values by 3 in this case is a horizontal blank of, we flipped our number, which is 1/3. That 1/3 is in between 0 and 1, so this is a shrink. Remember, I flip it and then I decide whether it's a stretch or a shrink. So that's how you would do the transformations here. Just reminded you about vertical and horizontal. Horizontal, you always have to flip your x value before you decide whether it's a stretch or shrink. Looking at e to the x plus 3. Start off with the graph of, again, our parent function is y equals e to the x, and then we're going to change it. The plus 3 is the only different thing. Plus 3 is a change in x, so remember it's an opposite sign. So instead of going right through, we're going left 3. So I would just put this in our calculator, get some ordered pairs, and graph it. Once we've used our ordered pairs to graph it, here is our graph. In this case, we still have an asymptote at y equals 0 because we haven't moved our graph up or down. Now we're going to look at the graph of e to the negative 0.5x. The first thing I'm going to do is look at that 0.5 and make sure I'm going to change it to a fraction because we're going to have to flip it, and 1 over 0.5 isn't going to be something easy to flip. So this is e to the negative 1/2 x. Again, our parent function is the same graph, y equals e to the x. The negative does something different than the 1/2. The negative is a reflection over the y-axis. It's going to change it to decreasing like we saw earlier. Then the 1/2 is right next to an x, so that tells me it's a horizontal blank by a factor of blank. Remember, you have to flip the number, so that means it's a 2. Then, since we have a 2, it's bigger than 1, that's a horizontal stretch. I'm going to go to y equals, clear out what I have. Second division sign gives me my e raised to the negative 0.5x. We don't have to put it in fraction form here. Graph it. We knew it should be decreasing, and it is. Second table gives us our ordered pairs to graph. And here's our graph. One thing I wanted to point out is that this graph is stretched horizontally, right? So it's not quite as steep as all the other ones. The last one is going to be your turn. There's one thing that I have to point out to you before you do this, though. You have to make sure that when you talk about the e to the x and then the transformations, that everything is in order. We are used to saying e to the x first, then plus or minus a number. So basically what I'm about to do is I'm flip these things. Remember, the negative has to go with the e to the x, and I'll put that in front and then do a plus 1. So this is the same thing as writing negative e to the negative 2x plus 1 at the end. Order matters. Put the e to the x first. Your turn. Here is your graph. Now that we've used our ordered pairs to graph it, a couple of things I want to point out is that the plus 1 tells us that there's an asymptote here, horizontal asymptote. Our asymptote has moved up to y equals 1. In this case, the graph appears below the y equals 1 instead of above it. This is the end of 5.2 notes. If you have any questions, don't hesitate to email or send a remind message.